I've had a few people reach out about expanding logarithms level 2, specifically on how to deal with radicals. So let me remind you of the radical property of being able to convert it into an expression that has a fraction exponent. So if you have some value a, that's not going to work. Let's choose another color. Hold on. Let's say you have a value a underneath a radical, and that value of a is raised to some exponent. We'll call that m, and the index of the radical is an n. We can rewrite this as a to a fraction exponent, a rational exponent. The m, which is the exponent in the inside of the radical, over the index value. This again, log of z y to the third power over the square root of x. Okay, I want you to instead see it as log of zy cubed over, well, let's take a look at this one. When the exponent is blank, it's understood to be a 1. When the radical index is blank, it's understood to be a 2. So we're going to put x to the 1 over 2 power. So when it comes to typing it out, the log expanded will be log z plus, because it's multiplying by the y cubed, log y cubed. Then it's going to have to subtract by the log x to the 1/2. But as I explained to you guys before, this exponent as well as this exponent, if it's not a 1, needs to move and become the coefficient of the log. So log z plus 3 log y minus 1/2 log x. So let's go ahead and type this out. So let me get my keyboard here. So typing the log, let's go back to, where is my ABC? Log z plus I need to do log again of y. Then I have to backspace there. Let me pause this a second. Okay, now that I finished typing it, here we go. Okay, so that's all you do. That's the only difference. So on this one specifically, you'll see that you would write that as z to the 1/3. Now, one thing I do want to bring to your attention on this one here, and I won't spend time typing it out, but let me rewrite this a second, because I have seen this happen with a few of you. Oh wait, sorry. So it's y over the product of, so that z has an invisible 1, so I'm just going to go ahead and write it as 1/3, and then it's multiplying, even though we don't have the dot there, it's multiplying by x to the 5th. So here's what I wanted to say. When you guys are writing this out, I've been noticing some students doing this. Let me go write this in. Okay, so what I'm noticing is students are putting a plus, because that is multiplication. But what you need to understand is that this was first mentioned in our problem, and that minus, which is this division that became a minus, is actually being minus to this entire thing. So in essence, what you need to realize is this minus is distributing to both of these. So this plus should actually be a minus. So what I want you to understand is that if you have a division with several terms being multiplied underneath that division goes with the z, and that division also goes with the x. So visualize it as having parentheses around the entire denominator, and thus when you write it out, it should be minus log z to the 1/3 power minus log x to the 5th power, because the distribution of the negative needs to take place. So for this particular problem, our final answer, the 1/3 has to come to the front, the 5 has to come to the front, and this is our final answer. So let's go type it over here to the left. Okay, so here we go. Typed it just like it's displayed, and there you go. Okay, so here is another problem that students are coming across, at least similar to this one, where you're wanting to use the calculator, and I want to show you how you will use the power chart and avoid using any handheld device. So the issue is not in rewriting, so let's go ahead and rewrite this as an exponential. So we start with the base of the logarithm, 256. We raise it to the power of -3/4, and we set it equal to x. So 256 raised to the power of -3/4 equals to x. Now what's wonderful is that this x is already isolated, but exactly how do we do this without just typing it into a calculator? Okay, so just watch what I need you to do. Let's see if there's a way of rewriting 256, okay? So let's come over here to our power chart, and we're going to see that 256 right here is written as 4 to the 4th power. 256 is 4 to the 4th power, okay? So let's come back and rewrite this as 4 to the 4th power. And then I'm just going to bring down that fraction power that was already there. Okay, so what you're going to notice is this 4 right here is in the numerator, because it's like saying 4/1. And this 4 is in the denominator, and we all know that 4 divided by 4 is going to give me a 1. So 4 now only has a -3 attached to it as an exponent, because 4 divided by 4 is a 1. Now, 4 to the 3rd power. Let's come back over here. 4 to the 3rd power is a 64, right? Well, if we know that 4 to the 3rd power is a 64, then 4 to the -3 is just the reciprocal of 64. Why? As mentioned before, if you have some value raised to a negative exponent, you merely can rewrite it as the reciprocal with the base to a positive value exponent, and vice versa. So this would be our answer for this particular problem. So I'm going to come over here, type 1/64, hit submit, and there's my answer. Okay, here's one last one. Rewriting this problem, x to the 1/2 equals 8. So here's another one. Students are like, I don't know how to work this out. So right now we need to isolate the x. In order to isolate the x, that requires me to be rid of this exponent. I want this exponent to disappear and become an invisible 1. So what can I do mathematically to 1/2 and be able to convert it to an invisible 1? Well, we know, side note over here, okay, we know that mathematically, if we take a half and we multiply it by its reciprocal, right, that this 2 and this 2, being that it's 2 divided by 2, would reduce to a 1, and 1 divided by 1 would equal a 1. So we're going to use that strategy to help us get rid of that 1/2 exponent. So x to the 1/2, I'm going to multiply that fraction by its reciprocal, because anytime you multiply any rational by its reciprocal, it's going to turn the number into 1. But because I just inserted this into my problem, whatever I do to this side of the equal sign, I must also make sure that this side of the equal sign also gets the same treatment, so to speak. So 1/2 times 2 over 1 is just going to be x to the 1 power. I'm not going to write the 1 power, equals 8 to the 2 over 1 power, which is just 8 squared. This now simplifies to 64. And that is it. So 64 is our final answer. No calculator needed. Hope these little strategies help you with today's assignment.